Have you ever felt déjà vu, a moment so familiar it seems you've lived it before? Most dismiss it as a brain glitch, but what if it's a glimpse into another you, living a parallel life in a different universe? The idea of parallel universes, or the multiverse, is no longer just science fiction. It's a serious topic in modern physics. Our universe may be just one of countless others, each with its own laws, histories, and versions of ourselves. Every decision, every chance, could create a new reality where the alternative plays out. The multiverse challenges our deepest assumptions, suggesting our universe is just a tiny bubble in a vast cosmic ocean. Science has repeatedly shown us that our perspective is limited. Earth isn't the center, our galaxy isn't unique, and perhaps our universe isn't either. The multiverse could be the next great shift, humbling us further and expanding our understanding of reality. The clues are faint, but they may be hidden in the very fabric of space and the quantum world. To find the origins of other universes, we travel back to the Big Bang, an explosion of space itself. In its first instant, our universe underwent cosmic inflation, expanding faster than light. The theory of eternal inflation suggests this process never stops everywhere at once. Imagine space as boiling water, with universes forming like bubbles. Ours is just one. Inside our bubble, inflation ended, allowing matter and energy to form stars and galaxies. But outside, inflation continues, spawning new universes endlessly. Each bubble universe is isolated, with its own Big Bang and possibly its own laws of physics. Some bubbles might be like ours, others so different that life or even atoms can't exist. The result, a cosmic landscape of endless possibilities, where our universe is just one successful bubble in an infinite foam. Eternal inflation doesn't just allow for other universes, it demands them. We are one outcome in an ongoing eternal process of cosmic creation. We can't visit other universes, but maybe we can see their fingerprints. The oldest light in the universe, the cosmic microwave background, CMB, is a snapshot of the early cosmos. In 2004, astronomers found a vast, unusually cold region in the CMB, the cold spot. Its size and temperature are hard to explain with standard cosmology. One theory, it's a bruise from a collision between our universe and another bubble universe. Such a collision could have left a void, making that region appear colder. While alternative explanations exist, none fully account for the anomaly. The cold spot remains a tantalizing hint that the multiverse might be more than theory. The multiverse isn't just a cosmic idea, it emerges from the quantum world too. Quantum mechanics tells us particles exist in a haze of probabilities, not certainties. An electron can take multiple paths at once, only choosing when we measure it. This uncertainty is famously illustrated by Schrödinger's cat. Until observed, the cat is both alive and dead. The paradox highlights the disconnect between quantum probabilities and our definite reality. The Copenhagen interpretation says observation forces a single outcome, but this feels unsatisfying. What happens to the other possibilities? Do they vanish, or do they play out elsewhere? This question led Hugh Everett to propose a radical alternative. In the 1950s, Hugh Everett suggested that all quantum possibilities are real. When a measurement occurs, the universe doesn't collapse. It splits, creating a new branch for every outcome. In Schrödinger's cat, one universe has a living cat, another a dead one. Every quantum event generates new universes, each with its own version of reality. You are not just one person, but countless versions, each living out different possibilities. These parallel worlds coexist with us, but are forever inaccessible. We experience only one path, which is why reality seems definite. The many worlds interpretation removes the need for mysterious collapse, treating quantum equations as literal truth. The cost, an unimaginable number of parallel worlds, each as real as ours. Our universe is just one page in an infinite book of realities. Two paths lead to the multiverse, cosmic inflation's endless bubbles and quantum mechanics' branching worlds. Some physicists hope to unite these ideas, but for now, they stand as separate arguments for a reality far larger than we perceive. Is any of it true? The evidence is intriguing, but inconclusive. The CMB cold spot could be a cosmic collision, or just a fluke. Many worlds solves quantum puzzles, but seems impossible to test. For now, the multiverse remains a logical consequence of our best theories, not a proven fact. To reject it, we must invent new physics. To accept it, we must embrace its staggering implications. Do you believe in parallel universes? The answer is still a matter of taste and philosophy. We have hints, not proof. And the search continues. Until then, we're left to wonder. Are countless other versions of you living out every possibility in worlds forever parallel to our own?